Welcome back to Math Defined, where math makes sense. I'm Mrs. C, and today we're diving into a topic that's all around us, probability. Have you ever wondered what the chance is of something happening like rolling a 6 on a die or winning a prize at a carnival? Today we're exploring theoretical and experimental probability, two different ways to describe how likely an event is to happen. You'll learn how to calculate each one, compare them, and even use probability to make predictions. Probability is the measure of how likely an event is to happen. It's always a number between 0 and 1. A probability of 0 means it won't happen, and a probability of 1 means it definitely will happen. We talked about this in an earlier video, how you can use a progress bar to show whether something is unlikely, likely, or somewhere in the middle. If you remember that, you're already ahead. Now that we have reviewed what probability is, let's look at the first type, theoretical probability. Theoretical probability is the kind of probability you calculate based on what should happen in a perfect world, where all outcomes are equally likely. Here's the formula we use. P is the event, or what you want to happen, is equal to the number of favorable outcomes divided by the total number of possible outcomes. This formula tells us how likely something is to happen before we try it. Now let's see how it works with an example. Imagine you're going to roll a fair 6-sided die. What's the probability of rolling a 3? There are 6 equal sides and only one of them is a 3. So using the formula, the probability of rolling a 3 is 1 over 6, which when divided is 0.166 repeating. We'll need to round this to the nearest thousand to get 0.167, and then move the decimal point 2 places to the right to get 16.7%. So theoretically, you have about a 16.7% chance of rolling a 3. But what if we actually roll the die and record the results? That's where experimental probability comes in. While theoretical probability is based on what should happen, experimental probability is based on what actually happened in a real situation or experiment. Here's the formula we use for the experimental probability, where P is the event, or what we want to happen, is equal to the number of times the event occurred divided by the total number of trials, or number of tries. This type of probability is based on the data that is collected for a specific event. Let's take a look at this example. A die was rolled 20 times and it landed on the number 3 6 times. Let's use the formula to find the experimental probability for this event. The probability of rolling a 3 is equal to 6 over 20, which when divided is 0.3 or 30%. So the experimental probability of rolling a 3 was 30%. It's based on what actually happened during this experimental trial, not just what was supposed to happen theoretically. So now that we have both the theoretical and experimental probability for this event, let's see how they compare. Our theoretical probability was 16.7%, but our experimental probability came out to 30%. That's a big difference. Why doesn't it match? In small experiments, results can be random, but as we do more trials, experimental probability tends to get closer to theoretical probability. Try it out for yourself. Roll a die 20 more times and use the formula to see how the experimental probability changes. Did it get closer to the theoretical probability of 16.7%? Share your results in the comments. I'd love to see your results. Remember, theoretical probability is a calculation of what should happen, and experimental probability is what actually happened. Let's use this idea to make a prediction using experimental probability. Let's say you've been flipping a coin during lunch break with your friends. You flipped it 50 times and it landed on heads 18 times. So your experimental probability for this event of getting heads using the formula is the probability of landing on heads is equal to 18 over 50, which when divided results in 36%. so the experimental probability for landing on heads is 36%. Now here comes the fun part. You're going for a coin flip challenge and plan to flip the coin 200 more times. How many heads should you expect to get based on your earlier results? We'll use the percent equation and the percent of experimental probability to help us calculate the expected number of times the coin will land on heads. The part is the expected number of heads equal to the experimental probability written in decimal form times the total number of trials. Multiplying 0.36 by 200 is 72. That means you might expect to get about 72 heads in those 200 flips. It's like using math to predict the future. Let's try a carnival game next. At the carnival, you decide to play a ring toss game. You want to see if you can toss a ring over either bottle number 1 or bottle number 4. What is the theoretical probability that you will be successful? We'll use the formula to find out. The probability of tossing a ring over bottle number 1 or number 4 is 2/7. Converting this into a percent, we get 28.6%. So theoretically, your chances of being successful are unlikely. But you decide to give it a try. It's a carnival after all. You played the game 28 times and made 5 successful hits. Did what you actually experienced match what should have happened? Let's compare. Your experimental probability using the formula is P, or the probability of tossing a ring over bottle number 1 or 4, is 5/28. Converting this into a percent, we get 17.9%. Your actual results were slightly less than expected. But as we've seen in this video, results like this can happen. But if you keep going, your experimental probability might get closer to the theoretical one. Remember, theoretical probability is what should happen based on a mathematical formula. Experimental probability is what actually happened. You can use both to make predictions and even win some carnival games. Awesome job today! If you found this video helpful and would like to support future math lessons, give it a thumbs up, send us super thanks, and hit subscribe. It really does mean the world to me. And if you watch this video all the way to the end, drop a die in the comments. I'd love to see who made it. Thanks for watching, and until next time, keep math awesome.